consisting of Jambres, Daniel, David, Mohammed, and myself, have set out to find a way to help provide access to clean water. Lack of clean water is a cause of death for thousands upon thousands of people every year. It is not that there isn't enough fresh water to go around, but that some places have more than others. Our challenge is to better provide information on the given fresh water sources we have and their conditions, to best allocate the resource to whoever and whatever is most at need. Our code is currently formatted for public information provided by the state of California on their bodies of water which are polluted and the type of pollutants. However, all 50 states in the US are required to provide similar information which our code could be modified to analyze.
Our final code uses data given to us by the state of California to encompass 9 out of the 12 regions given to us. And this is true, or this is necessary, because there's only 9 regions which contain water bodies, while the 3 regions that are not in this data set do not have water bodies. And talking about the water bodies, we have water body names and water body types. And we need this information because this provides us with whether the pollutants are going to be mobile or stationary. And now they're stationary whenever it's not in a moving water, such as rivers and streams. And this usually means that the pollutants would be in the bed of such locations. And mobile would mean that the water moves the pollutants within itself. So it gives a more or less even concentration of pollutants within the water bodies. And our next 2 columns here encompass the units and the affected size. And this is very important because it tells us the magnitude of the pollutants that are within such water bodies, and it gives us an idea of how many people more or less will be affected by either how big or how small the affected size is. And our sizes are only in 2 units, miles and acres. Acres are used for stationary water bodies such as lakes and reservoirs, and miles will be used for only mobile water bodies such as rivers and coastal streams. And the last but not least is pollutants, and pollutants are very important to our code. That is our pinnacle, because it explains to us what we should be worried about whenever it comes to acknowledging such water body. And depending on the pollutants gives us an idea of how bad the magnitude of such pollution is, and whether we should place some regulations with having people receive water out of there, or having companies export water from such location. And it also gives us a sense of who is responsible for the pollution of such water body.
So in our MATLAB script, we load in our data, which is called edit.xls. Then the next thing we do is we make a region menu choice. So there's 9 regions in our data, and so the first thing we have to do is analyze the size of our inputted data, and so we get how many rows, how many columns from just using the simple size command. And then we initialize the first region into this vector v, and so we just say t of the first row in the first column, and so that'll be region 1. And then we initialize the location just as 1 because it's in the first row. So then what we do is we write a for loop that gets rid of all repeated region names. So by doing that, how we do that is we just do a for loop from x equals 2 all the way to the amount of rows, and we do a string compare of the current iteration of the loop. So the first one would be t of row 2 column 1 compared to t of row 1 column 1. And so if they're not equal to each other, if they're different strings, so if it goes from region 1 to region 2, we'll set the location, what row that's in, we add that to the already existing vector location, and then we add what the string is to this vector v. So we keep what we had and we add whatever the new string is. It's column. And so WB is equal to T, which is our Excel spreadsheet, of all the rows but just the second column. And so that just gives us a nice simple column array of cells. And so then if the user chooses region 9, then the choices that they'll have of water bodies will be of whatever the listed water bodies from the location of region 9 all the way to the end. But if the user chooses regions 1 through 8, either of those, they'll use water bodies of location of whatever the choice is all the way to location +1, -1, meaning that it's, so say they choose region 1, it'll take the location of where region 1 starts, so that'd be the first row, all the way to region 1 cell before region 2, because then that's all the values for all the different water bodies for region 1. So then what we do is, in our data, if there's different kinds of pollutants, then it repeats the water body name. And so what we do is we run this for loop similar to the one we ran for regions for water bodies, just to get rid of any repeated water body names. And so then we output the information. So what we're outputting here is how large the area affected is, the units, like how many units, and then what kind of water body it is, and then is polluted by, which is classified as whatever water body type, polluted by, and then we list what it's polluted by. And so when you run this, it just outputs the first line saying the size, what water body, what region, and then it says all the different pollutants. And that's our code.
Now we're going to go ahead and begin test case number 1. So first thing is we'll run the code. The first thing that will come up after running the code will be the menu, the first menu. Choose a region, so we have 9 different regions to choose from, and we're going to go ahead and click on Regional Board 1 North Coast region. The second menu will allow us to choose a water body name for our region, and now we're going to go ahead and choose Cocoa Lake. As you can see, the first thing that came out in the result was 776 acres of Cocoa Lake, which is classified as a lake and reservoir is polluted by Cyanobacteria hypotoxic macrosustance. Now we're going to go ahead and do another case. In this next test case, we're going to try to do Regional Board 3 Central Coast region, but before we do that, we're going to try a data validation, which if we try clicking the X from the menu will continue going on until we choose different regions. So we go ahead and click it again, the menu will come up again until we choose a regional. So Regional Board 3 Central Coast region, and after that, choose the water body name yet again, and in this case if we tried clicking on the X, it will give us other water body names because we couldn't manage to fit all the water body names in one menu option. So if we click the X right here, we're going to get another selection of menus, and if you clicked another X here again, we're going to get another selection of water body names. And if we click X the third time, we're going to go back to the original water body name selections. So we're going to go ahead and click on Aptos Creek, and our result was 8 miles of Aptos Creek, which is classified as a river and stream, is polluted by bath cones and sedimentation siltation. Thank you so much for watching.